So the difference between structured programming and object-oriented programming is that structured programming is older and it's more top-down logic than nonlinear. For example, in object-oriented programming, you can have function calls and the logic can go all over the place instead of just going from top to bottom. And structured programming is more concerned with procedure, while object-oriented programming is more concerned with representing models or objects. And structured programming is closer to assembly language, therefore it's lower in abstraction than object-oriented programming. A data structure is some kind of method for storing and organizing data on a computer. Examples are classes, arrays, structs. It doesn't count as data itself, but a way of organizing data. A class is a kind of data structure that can hold both data and functions, and data of different data types, unlike an array. You can think of a class as a template for creating objects. The class itself isn't a real object, but the class can produce objects. So you can think of it as a cookie cutter creating cookies as an example. There can be one class, but that class could have many instantiations. Each object has its own individual identity. So a class is a template or a set of actions and attributes, and an object is an instantiation of this template. So we can imagine that a class can be like a fruit, and object can be a specific fruit. For example, apple and oranges are fruits. Both are objects of the class fruit, and they have similar attributes because they are both from the same class. They also have the same action, which is to cost something. First, create a fruit class. And don't forget the semicolon at the end because this isn't a function declaration, it's a data structure, just like an array. In C++, there are things called access specifiers. There's private, public, and protected. And all data members are private by default. So let's just make it public so it's available anywhere in the program for simplicity. So each member of fruit class will have the following attributes: price per pound and weight. Besides having attributes, members of a class can have actions or functions, methods. Basically, they're just functions. They can be declared inside the class or they can be declared outside the class, which is what we will do. Since we're declaring the function outside the class, we have to use the scope resolution operator, which is the double colons, to signify that's a member of the fruit class. And the function will return the cost of the fruit based on the weight and that price per pound. So set up the main function. Apple and orange will be objects of the fruit class. We'll use cin and cout statements to allow the user to enter data about Apple. So you can enter the price per pound and the weight of apples. And likewise, we'll do the same for object orange. We enter data from the keyboard about orange. So the function of the fruit class will output the cost of each fruit. So in the console window, we can see this happen to make sure it works right.
In this tutorial, we will be taking an introductory look at object-oriented programming in C++. Here we will look at classes and objects and their various components. We will look at the basic types of class operations such as constructors, destructors, setters, and getters. Finally, we will look at the keywords private, public, and protected. When you're done with this video tutorial, You may want to check out the link in the video description for some example code. Also, you can move on to the next video in the Object-Oriented Programming series, Inheritance. Object-oriented programming is a programming methodology that focuses on modeling data and functions as objects. By contrast, procedural programming focuses on program execution, statement by statement. In a way, object-oriented programming is more abstract, while procedural programming is closer to the raw machine instructions. Object-oriented programming is how the majority of apps are made today. It's essential to game programming and making the kinds of apps you might use on your phone or tablet. Object-oriented programming is a good way to design programs in an efficient and intuitive manner. Objects give you a high-level concept to start with so that you can design first and code later. Object-oriented programming is also a good way to encapsulate data and keep components functionally separate from each other. If you create a linked list class for one program, you can easily reuse this code in another program as long as the linked list class is self-contained, meaning it doesn't rely on external code to do its job. In general, we can think of an object as something with a unique identity. This is true in the real world as well as in the software world. A bike, for instance, is an object with a unique identity since it occupies a unique location in space and time. Also, it possesses its own set of attributes and behaviors. Attributes may include the brand name, color, and price. Behaviors may include pedal, brake, and change gears. In object-oriented programming, a class is a template for creating objects. The template is a particular set of attributes and behaviors. Objects implement these attributes as data, and behaviors as functions. A class is a data type, and an object is a variable of that class. In general, objects have two basic methods, the constructor and the destructor. The constructor is what instantiates the object and allocates dynamic memory as needed. The constructor that takes in parameters is called a normal constructor, while a constructor that does not is called a default constructor. The destructor is used to deallocate any dynamic memory used by the object. The destructor is called at the end of the object's lifespan, or when the program terminates. Besides constructors and destructors, objects have two other kinds of methods, setters and getters. A setter is a method that changes the data attributes of an object. For example, setPrice will take a floating point number as a parameter and set the price variable to the value passed in. A getter method retrieves the data of an object. A getter doesn't change an object, but rather lets you peek inside of it. For example, we can give the bike class a method called getPrice that returns the value inside the price variable. In C++, there are certain key words for controlling the access level of the data members and methods of a class. Private means that the class members are only visible to the class itself. Usually, data members are private so that you can access them only through the setter and getter methods. Protected means that the class members are only visible to the class and its derived classes. Protected is used in inheritance chains. We will cover inheritance in the next tutorial in the Object-Oriented Programming series. Public means that the class members are visible to entities outside the class. Typically, most class methods are public so that they can be called from outside the class. Public methods are like the windows that let anyone see into your house. They are also like windows that let you stick your hand in and rearrange your furniture. Inheritance is the process of passing the attributes and behaviors of one class down to descendant classes. For example, you can start with a class like Reptile then have its descendants be snake and alligator. Although snake and alligator have different attributes and behaviors, both classes are derived from the same reptile class. Composition is the process of making one class a data member of another class. In a way, one class is embedded in the functionality of another. For example, you could have a class called band. The data members of band could consist of objects from the guitarist class, drummer class, and vocalist class. None of these classes are derived from each other. Instead, one class is using the objects of external class. Inherited classes are commonly described as having an is-a relationship with each other, while composition involves a has-a relationship between classes. We can say that snake is a reptile and that alligator is a reptile, but we cannot say that guitarist is a band. Instead, we say that the band has a guitarist. Sometimes, a friend function is included in the method declarations of a class. The friend function is not a true member of the class. Instead, it is the signature of a function that is external to the class. The keyword friend lets the function have access to the private data members of the class. Friend functions are commonly used for overriding the IOStream operators so that you can print the contents of an object using the double angle brackets rather than a local print method. In the previous video, we looked at three kinds of access specifiers in C++: private, public, and protected. Remember that private data members are only accessible to the class that contains these members. By contrast, public data members are accessible from outside the class. Protected is like private plus. Only the parent and the child classes have access to the protected members of the parent class. Note that the direction of inheritance is hierarchical and one-directional. Derived classes have access to all the protected members of a parent class, but the parent classes don't have access to the members of their child classes. Here's an example. Suppose we have a class named quadrilateral. This class is the template from which we build four-sided polygon objects. To demonstrate inheritance, let's give the quadrilateral class a child called rectangle. Rectangle objects have all the attributes of quadrilateral with one additional property. Rectangles not only have four sides, the interior angles must each be 90 degrees. Let's make another child class of quadrilateral called trapezoid. Like rectangle, trapezoid has the attributes of quadrilateral. Trapezoid inherits the traits of quadrilateral, plus the trait of having a parallel top and bottom. For fun, let's create a class called square. Square inherits all the attributes of rectangle and gains the requirement of having side lengths all be the same length. To learn more about object-oriented programming in C++, please see the next video in the series, Polymorphism. To get the complete coding example for the tutorial you just watched, please visit the link in the video description. Thanks for watching. In this tutorial, we will be looking at polymorphism in C++. Like inheritance and composition, polymorphism is another fundamental concept in object-oriented programming. Basically, in polymorphism, you start with a vague description for a family of objects. From there, you can make the description more specific depending on the context or particular family member. This video is a follow-up to the previous video on inheritance in C++. It's important to be familiar with classes, objects, and inheritance before you proceed. It's also crucial to be familiar with pointers and memory allocation in C++. All the example code for this tutorial is available to copy and paste into your own project. You can find it by clicking on the link in the video description. Polymorphism comes from the word polymorph, which literally means a thing with many forms. In object-oriented programming, Polymorphism is the ability of an abstract base class to take on multiple forms through its derived classes. An abstract class is a class that cannot be instantiated as itself. Instead, it serves as a base class from which more concrete classes inherit their attributes and behaviors. In our example, Polygon is an abstract class. Therefore, we cannot create polygon objects. What we can do is create objects of its derived classes, triangle and quadrilateral. In C++, an abstract class has at least one virtual function. A virtual function is a method in a base class that must be overridden by its derived classes. We declare the virtual function with the keyword virtual and set the function to equal 0. Let's give the polygon class two virtual functions, getArea and getPerimeter. Note that we cannot determine the area or perimeter of a generic polygon since we don't know anything about its specific dimensions. It's impossible to measure the area and perimeter of a polygon unless we know the number of sides and each of its side lengths. Still, it's useful to include the area and perimeter methods as virtual functions in the base class since they describe essential components of any polygon. Basically, a polygon is a two-dimensional space enclosed within straight edges. The minimum number of edges is 3, so we can start implementing the virtual methods of polygon in triangle. We can find the area of any triangle by using Heron's formula. Let S equal 1/2 times each of the side lengths of the triangle. Then, we can compute the area as the square root of S times S minus side length A, S minus side length B, and S minus side length C. To get the perimeter, we simply add up the side lengths. For any cyclic quadrilateral, a quadrilateral that can be inscribed in a circle, we can compute the area by dividing the quadrilateral into two triangles, and then using Heron's formula to compute the area of each triangle. Finally, we add the areas of each triangle to get the total area of the quadrilateral. To get the perimeter, we simply add up the side lengths as we do in triangle. Now that we have an idea of how polymorphism works, it's time to start programming. In the video description, you can copy and paste everything you need for a working example. Just visit the link in the video description. You can see how abstract classes can be used to declare virtual functions, as well as create pointers to objects of derived classes.